Welcome to this explainer. Today, we're taking a seriously fascinating look into the mechanical engineering of the human jaw. I mean, we use it every single day, right? To talk, to breathe, and obviously, to eat. But how often do you actually stop and think about the complex system of biological levers, pulleys, and engines that make a simple bite possible? Well, today, we're going to decode the muscles of mastication, those anatomical powerhouses that drive one of our absolutely most essential daily functions. Let's get right into it. Okay, let's dive into this. I want to kick things off by asking you a quick question. When you think about chewing, you probably think about the sheer force required to crush your food. But what about just opening your mouth? Out of the core group of muscles that control your jaw, what is the only principal muscle designed specifically to drop your jaw? Keep that question in the back of your mind because it sets up a really fascinating mechanical imbalance, what I like to call the rule of the exception, that we'll uncover a little later in this explainer. To get there, we're going to break this whole complex system down into 5 straightforward steps. First up, the mechanics of chewing. Then we'll look at the principal muscles, contrast opening versus closing, check out the accessory assistance, and wrap up with the nerve command center. All right, Section 1, the mechanics of chewing, engineering the bite. To really grasp this, we have to stop looking at the lower jaw, the mandible, as just a piece of bone. Instead, we need to view it as a highly dynamic mechanical lever system, one that moves on a specialized hinge we all know as the Temporomandibular Joint, or TMJ. So the crucial point here is that before we examine these muscles individually, we've got to understand the 5 foundational ground rules that group our main chewing engines together. Think of these as the biological design specs. Number 1, they're all located in or right around the infratemporal fossa. That's the space just deep to your cheekbones. 2, they all insert into the ramus of the mandible, which is that vertical ascending part of your lower jawbone. 3, they get all their electrical signals from the exact same source, the mandibular division of the trigeminal nerve. 4, their sole concern is creating movement at that TMJ. And 5, from an embryological standpoint, they literally all develop from the exact same tissue, the mesoderm of the first pharyngeal arch.
Moving on to Section 2, the principal muscles, the engines of mastication. We've got 4 main engines here, and honestly, I want you to actively engage with them as we go through this.
First up is the temporalis. Try this. Place your hands on the sides of your head, just above and slightly in front of your ears. Now clench your teeth together tightly. You feel that? You can literally feel this muscle bulge right beneath your fingers. It's a massive, beautifully fan-shaped muscle covering the temporal fossa. Now, it actually has a dual action depending on which fibers are firing. The anterior fibers pull straight up to elevate the jaw and close the mouth. But the posterior fibers, the ones running toward the back, they pull horizontally to retract the mandible, basically pulling it backward after it's been pushed forward. And this brilliantly illustrates our next engine, the masseter. Move your hands down to the flat sides of your jawline, right over your back teeth, and clench again. Bam, that rock-hard muscle you feel popping out, that is the masseter. The name itself actually comes from the Greek word for a chewer. It's a thick, tough, quadrilateral muscle spanning from the cheekbone, the zygomatic arch, straight down to the ramus of the mandible. This guy is your absolute powerhouse for a forceful bite. Whenever you're crushing down on a really tough piece of food, the masseter is the one doing the heavy lifting to forcefully elevate your mandible. Now let's see how this builds with our last 2 principal muscles, the pterygoids. These are tucked away much deeper inside, so you can't really feel them from the outside like the others. First, we have the medial pterygoid, which is essentially the masseter's deep-seated mirror image, helping to elevate the jaw and close the mouth. And then we have the lateral pterygoid, which is this short, thick, conical muscle. The lateral pterygoid is widely regarded as the key muscle of the infratemporal region. When both sides contract together, they pull the neck of the mandible forward, protruding the jaw. And when the medial and lateral pterygoids of opposite sides fire alternately, that's what gives us that complex, side-to-side grinding motion that is absolutely essential for chewing our food. Which brings us to Section 3, opening versus closing, the jaw's tug-of-war. We've met the engines, sure, but how do they actually interact? Well, it turns out there is a wild mechanical imbalance in the jaw's muscular system. It is literally a biological tug-of-war. Remember that hook question I asked you at the very beginning of this explainer? What is the only muscle designed to drop your jaw? Well, here is that rule of the exception in action. Look at this setup. You have 3 incredibly powerful elevators totally dedicated to closing the mouth, the temporalis, the masseter, and the medial pterygoid. And fighting to open the mouth, there stands a single principal depressor, the lateral pterygoid. It is the one and only principal masticatory muscle that opens the mouth. Now sure, gravity helps a bit, but mechanically speaking, you've got one primary muscle working in direct opposition to three massive closers. Crazy, right? Taking a step back to look at all four principal muscles side by side, this perfectly synthesizes all that data. Notice where each engine anchors, its origin, and where it applies its force, the insertion. And definitely notice, once again, the lateral pterygoid standing completely alone with depression sitting right there in its action column. It's a great summary of exactly how these interact. Moving right along to Section 4, the accessory assistance, supporting the bite. Now you're probably thinking, if the lateral paragut is outgunned 3-to-1, how do we ever manage to open our mouths widely or against any real resistance? Well, the jaw doesn't have to rely entirely on the lateral pterygoid for opening. When you really need to open your mouth widely, say to bite into a huge apple, or if you're trying to open your jaw against heavy resistance, a backup crew steps in. These are the accessory assistants: the digastric, the buccinator, the mylohyoid, and the geniohyoid. Generally speaking, these muscles sit a bit lower down, right beneath the jaw. When they're called upon, they contract to help depress the mandible and drop that jaw wide open. But I really want to highlight one accessory assistant in particular, just because it has such a cool, highly specific job: the buccinator. It's often called the trumpeter's muscle or the bugler's muscle because it allows you to forcefully expel air from your cheeks. But its role in chewing, absolutely vital. It flattens the cheek right against the gums and teeth. Now, why does this matter? Because without the buccinator continuously sweeping the sides, food would literally just fall out of the chewing path and get stuck in the vestibule. You know, that awkward space between your teeth and your cheeks. It's basically the ultimate biological conveyor belt, keeping your food perfectly positioned for the next bite. And finally, Section 5, the nerve command center, wiring the system. Look, mechanics and engines are completely useless without an electrical control system to run them. So let's take a look at the wiring that makes all these muscles fire exactly when they're supposed to. Now, what's really interesting about this setup is that despite all these muscles having totally different shapes, different locations, and very different mechanical jobs, almost all of the principal actors take their orders from the exact same nerve. The mandibular division of the trigeminal nerve is the primary neural pathway that carries motor commands down from the brain. It acts as a highly organized command center for the entire jaw. Let's look at how that command center actually delegates. The main trunk of the mandibular nerve gives off a specific branch right out of the gate, the nerve to the medial pterygoid. Then the nerve splits, and its anterior division specifically targets the rest of the principal muscles. You've got the masseteric nerve shooting out to power the masseter, the deep temporal nerves travel up into the temporal fossa to fire the temporalis, and the nerve to the lateral pterygoid connects straight to our lone depressor muscle. It is just a stunningly direct and efficient wiring diagram. It ensures that when you decide to chew, that whole complex sequence of elevation, retraction, depression, and side-to-side grinding happens absolutely flawlessly. Which leaves us with this final thought to ponder. We've seen that the jaw is this delicate, incredibly complex tug-of-war. You have three massively powerful muscles constantly trying to close the jaw, while essentially one main principal muscle, the lateral pterygoid, works to pull it open and glide the articular disc of the joint forward. Think about that imbalance for a second. If there is even a tiny misalignment, maybe an overclosure or a bad bite, and that intricate balance gets disrupted, the articular disc can become stretched or trapped. And honestly, that's exactly what happens when people experience a clicking, painful, or locked temporomandibular joint, or TMJ. It's a harsh clinical reality born straight out of this incredible mechanical anatomy. It really leaves you marveling at the fragile, beautifully engineered balance of your own jaw, doesn't it? Next time you take a simple bite of food, just remember the delicate tug-of-war happening right beneath the surface.